Thanks to all of our sponsors for making the CyberWire possible. If your company would like to reach 250,000 unique listeners every month, send us a note at thecyberwire.com/sponsor. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts, tracking down the threats and vulnerabilities, solving some of the hard problems of protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
It actually was for fun, the exploitation part, but the main purpose of the research was to deeply understand how things are working to better detect it in the platform.
That's Gafneet Amiga, Director of Security Research at Lightspin. The research we're discussing today is titled AWS RDS Vulnerability Leads to AWS Internal Service Credentials. Imagine a Ferrari losing Le Mans to a 40-year-old Pinto with a broken headlight and two flat tires. That pretty much describes the very asymmetrical cybersecurity industry. Money never solved the hacking problem. At CrowdSec, they want to rebalance the odds and make security available to all for free. Their open-source, massively multiplayer firewall analyzes your visitor's behavior and deals with malicious traffic. Once an aggressive IP is identified, it's also shared across all users to ensure everyone's protection. No matter what your business size is, it offers an adapted response to credential stuffing, port scans, password brute forcing, and much more. At CrowdSec, they have each other's backs and make the internet safer together. Want to join the community and protect your IT assets? Visit crowdsec.net to learn more. And now, a word from our sponsor, Keeper Security. Keeper is the top-rated cybersecurity platform for protecting organizations of all sizes from the most common password-related data breaches and cyber attacks. Did you know that 81% of data breaches are caused by weak password security? Keeper is more than a password manager. It's a scalable and customizable security platform that includes industry-leading features such as automated user provisioning, role-based enforcement policies, SSO SAML integration, advanced reporting compliance, breach-watch dark web monitoring, and more. Members of the CyberWire community will receive a free 3-year personal password manager when they take a business demo. Visit keepersecurity.com/cyberwire to learn more. And we thank Keeper for sponsoring our show. Well, for folks who may not be familiar with Amazon Elastic Kubernetes Service and all of the stuff that you're working with here, can you give us a little bit of the background, a little description of how all this stuff works?
Yes. So Kubernetes is the containers orchestration platform that was created inside Google. EKS is a managed Kubernetes service. It's really complicated and hard to maintain a Kubernetes cluster. Even just to create it, it can be difficult sometimes. So what Amazon are doing is to give us like a black box, all the control plane area. They create the cluster for us. They maintain the control plane. And you can have access to the data plane, and you can just start and connect your client to the cluster and start deployments on Kubernetes. It should be easier to work with that and maintain it. And EKS is that managed service.
Well, that all sounds great. Walk us through your research here and how you discovered some vulnerabilities.
In EKS, the research question was first, like how EKS performs the authentication. because they are able to identify you as an AWS IAM identity. In AWS, you have users, you have roles, you have groups, and in EKS, you can stay logged in to the terminal as an AWS identity, let's say an IAM user or role, and you can perform actions against your managed Kubernetes cluster in EKS. So the question was how it's done and to deeply understand it. And in Noga's research, you can see exactly how they're doing that. She specified that there is a config map inside the kube system namespace. And this config map, the AWS auth config map, there is a mapping between AWS identities and Kubernetes identities. And the code that is running in the control plan by AWS is the code that of the AWS authenticator for Kubernetes. This is an open source code that was developed first by Heptio and then moved to AWS EKS themselves. And they're using this code and deploy this service inside the managed Kubernetes control plan. You cannot see it, you cannot access it, but it's there, or like some kind of version of it. And the logic there is written in that code. And by researching the code and doing a code review, you can see what is the exact logic of how things are being translated between the AWS identity and the Kubernetes identity. And when I did the review and the debug, I locally installed it, and just to play with it, to be able to play with it, I saw that there are multiple parameters in the request that they are looking in order to decide what is going to be the Kubernetes identity they are going to map to. They want to figure out eventually what is going to be the Kubernetes username and Kubernetes group. And in order to do that, they're using AWS service and endpoint, which is STS get caller identity. In AWS STS get caller identity returns back the logged in user identity. So they use this endpoint in order to get back the user identity, and then they take this identity and map it using the config map to a Kubernetes username and group. So in the way they are using the STS get caller identity endpoint is that they're requesting the user that access the cluster to send a signed request to STS get caller identity endpoint. And the signed request is signed using the AWS credentials, the access key and the secret of the IAM user in AWS. When you go over the code, there is a section when they take the signed request parts. So there are multiple parameters that are being passed as part of this request, but one of the parameters is, for example, what is the access key ID of the user that signed the request. So there are multiple parameters being parsed in the request, and they are taking these parameters and using a to-lower function in order to save it. So there is a kind of a trick that you can pass the same parameter name twice, and then you sign the request with both parameters, but one is like with uppercase and one is with lowercase parameter name. And what happens is that the EKS cluster will take one of the two, because it depends on the ordering, but it will take one of the two. So we want the cluster to take the malicious one, the one that we're going to manipulate the value of the access key ID. And the STS in AWS will take only the one that he is familiar with. He will not, it will just ignore the STS service itself, will ignore the manipulated parameter as long as it's signed as part of the request. So this is exactly what I did. I passed both I passed twice the same parameter name in the request and signed it. And then what happened is that EKS took the malicious access key ID and translated it into like a different user. So you can trick it to think you are another identity in the cluster. This can lead to a privilege escalation inside the cluster. It depends on how the mapping in the AWS auth config map is configured. This is the technical issue. So it's led to a privilege escalation inside the cluster.
And has the EKS team addressed this?
So what they did is to check that you are not passing the same parameter name twice. They allow you to pass it only once, and then it prevents the attack.
I see. So is this fixed now? Is this been patched?
Yes, it was patched and it was fixed. Actually, it was patched very quickly, and now all the EKS managed clusters are fixed. But if you're using the open source of the IAM Authenticator, or that you're using EKS Anywhere, which is the on-premise version of EKS, then you should take an action and to update this service by yourself.
What do you make of this vulnerability in terms of how this code was written and the functionality that they were intending to have happen and the resulting bug? I mean, do you have thoughts on how this sort of thing comes to pass?
Well, I think that the service is written really good. You can see in the issues, you can see that they're in the pull request, you can see that they are taking into account all the security aspect. They have blocked many other leads that I thought that I will be able to exploit in the code there. They heavily thought about security while they created this extension. It's tricky. It's always tricky to enforce the connection between two services, and in this case is Kubernetes authentication and identity and AWS identity. It's always tricky, but I get the need to ease the usage of the end user at the end. But I think that here also when you look the way they treat it, so they took it very fast from the moment you report to the moment it's deployed in production, the fix. So I think it's a good balance here.
You mentioned when we were first speaking that part of your reason for digging into this was fun. Was it fun? I mean, it sounds to me like this is the sort of thing that you and your colleagues really have a good time with.
Yeah. It's always interesting because you start just by researching to understand how it works, but then things start to come up to your mind like, and what if, and if I will change that into that, how it will react. And you always save it to a later time, and when you have the time, you try to play with it. So it is, for me, it's fun.
Our thanks to Gafneet Amiga from Lightspin for joining us. The research is titled AWS RDS Vulnerability Leads to AWS Internal Service Credentials. We'll have a link in the show notes. Thanks to all of our sponsors for making the Cyberwire possible. Bacon does a body good, but so does sponsoring our program. If you like bacon, send us a note at thecyberwire.com/sponsor, because everything's better with bacon. The Cyberwire podcast is proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. Our amazing Cyberwire team is Rachel Gelfand, Liz Irvin, Elliot Peltzman, Trey Hester, Brandon Karpf, Eliana White, Paru Prakash, Justin Sabi, Tim Nodar, Joe Kerrigan, Carol Terrio, Ben Yellen, Nick Valecki, Gina Johnson, Bennett Moe, Chris Russell, John Petrick, Jennifer Iben, Rick Howard, Peter Kilpie, and I'm Dave Bittner. Thanks for listening. We'll see you back here next week.